And then I'll sit down. Yeah.
Testing. I think there's one down there.
Just speak. Don't make a phone call while you're presenting.
So you see the clicker?
Get the clicker.
Is that it?
I don't think this is it.
You know where the clicker is?
Is this it? There we go. Green.
It's 5:15 on the last day of the conference, and you're all here. You all rock, man. Give yourselves a hand. That's awesome. So you're here to see Hadoop by George to wrap up the conference. I'll let George by doing an intro, and then I'll do the same.
Hi, guys. My name is George Bertikaden. You guys can call me George V. I am an architect at Hortonworks. So what I do is I actually work in the field. So I work with customers directly to essentially help them design, architect, and start the implementation of a use case that involves Hadoop. And these are typically customers that range from first time around to pretty experienced customers. So I get some insight into architectures that worked and that have failed. And hopefully by the end of this, you guys gain some insight from that.
And thank you for joining us today. I'm not sure what this means anymore, except to say that I've spent a lot of time down in the coal mines. I know where the dead bird sections are, and I can keep you away from them. And I think maybe that's probably the most important thing to glean from that. You've been to a lot of presentations today and yesterday, and you've heard a lot of discussions of why people are moving to Hadoop. If I could hear from you all, because I'm sure you've all learned a tremendous amount, right? What would you say would be the top 2 or 3 reasons people look at going to Hadoop and away from these traditional systems? Give me your top 2 or 3. Scalability? What else? Price? Looking at storage? Give me one more. Late binding. When we look at customers that are looking at going to Hadoop, typically the #1 thing that they say in terms of why they start looking at it is the price of storage. When we ask customers why they're using Hadoop 6 months later and what the #1 benefit is, they say storage, but it's always last on the list. The one thing that I hope you glean from this conference, a couple things is, one is Hadoop is something that customers are moving to because if your competition is making faster and more accurate business decisions than you are in a tremendous amount of trouble, right? Now, I'm sure you've also been learning about Hive and Pig and MapReduce and all the different enterprise tools that can run on top of Hadoop, but we don't want to lose sight of one of the most important factors when you look at having a Hadoop project and building a Hadoop cluster and being successful with it. It's still all about the data. That's the most important key. The other thing that I've been hearing quite a bit when I talk to people is they're saying, wow, learning Pig and Hive and all these things, it's a little overwhelming. And sometimes people get intimidated saying, are my existing skills, how valuable are they going to be in this new environment, or I'm starting over? The thing that you have to remember is because it's about the data, if you've ever worked on any type of data warehousing, BI, or analytics project, all the knowledge that you glean from those projects, you are going to use in a Hadoop clustered environment. It's just understanding how to spin the data a little differently. So some of the things that kind of stand out that you should have gotten from the conference this week is, one, some of the most valuable data that customers are working with today is not their traditional structured data. It's often that unstructured or machine data that they're trying to deal with, and our traditional systems are just not very effective or efficient in working with it. Two, As we have larger and larger data volumes, we're also seeing that our existing systems do not give us the capability of making accurate decisions because storage is so expensive. When we are throwing data away, when we are aggregating and filtering data, we're losing the information of the details that impacts our ability to make accurate business decisions. One simple example is Microsoft was looking at changing their algorithms, their grammatical algorithms for Word, and they brought in some people to take a look at the algorithm, said we need them to get better, and they were looking at designing new ones. What they decided to do first was saying, let's see what's wrong with the existing ones. So they ran those algorithms through 1 million records, and then they did it through 10 million records, and then 100 million, and then 1 billion. And what they found is the more data that those algorithms looked at, the more accurate they got. And one of the things that you're going to see in your organizations, the more detail that you can look at in your information, the more confidence that you're going to be able to have in the business decisions that are coming out of that data. The other thing is, someone mentioned it, business latency will kill an organization. If by the time we get data, if it takes us a long time to be able to use that data and leverage it for business decisions, we are in a world of hurt. Now, if I asked you to say, if you're going to spin up a new data warehousing project, and you were going to start with a new source of information, if I asked you how long it would take to spin up that data warehouse, most people are going to say 3 to 6 months on average, and you all understand if it's a new source of data in this type of industry and how quickly things are changing, by the time that data warehouse is in place, a lot of that information has changed, the structures have changed, you need to change the schemas, and your business has not been using that information to make business decisions. So what you want to be able to do is, when you work with this new technology, you can't use it the same way you did your old technology. You've got to have higher expectations, and you've got to change the mindset of the people. We want to be able to get our data to our people faster to make better decisions. So what I want you to glean from all these things that we're showing here about traditional systems is when you start working with Hadoop, making sure that you solve these issues, your processes, your methods, your best practices, are making sure that you don't create the same problems in your Hadoop cluster. Because the hardest thing to change is not to teach you advanced things of what you already know, it's to teach you new things. So what you get with the Hadoop-based ETL platform is, one, it's first of all going to address the ability to work with unstructured data and also very large volumes of data. Two, we've talked about the linear scalability that you have of working with a Hadoop cluster. The other thing that I see customers do wrong is the same thing they did in data warehousing projects, is when they decide to do a POC or do a benchmark, it ends up being a scientific experiment that has nothing to do with reality. What they just want to do is see how much data they can push to their system and what the disk latency and what the IOPS are. Well, what does that have to do with you picking the right architecture and the right hardware, the right configurations for the Hadoop cluster that you're going to be working with? So make sure that you find some way to create some level of realistic workloads when you do your POC to make sure that when you're done, you have an understanding of what the bottlenecks are going to be for the volume and the type of data that you're going to be working with and the volume of concurrent loads that you're going to have as well. The other thing is we can get all excited about Hadoop, but the people that are going to be supporting that environment, they're scared to death because they know that once we go production, we have to support that environment, and if you're new, they probably don't have the skill set to think that they can troubleshoot it and do it effectively. So I also recommend that when you do your POCs, and make sure that as you start to test that system and get the results that you need, that you also break that system. You test your monitoring, you test your alerts. You start to use that POC to also build the skill set of your people that are going to be supporting that environment once your users start working with it. The other thing that we're seeing here, and I'm sure you're seeing the same thing as well, is it's not that it's just unstructured data or it's large volumes of information. With all the regulation that's going on in the health and finance and all the other industries, that regulation is requiring that companies keep data around a lot longer. And what customers are also seeing is as they keep data around longer, they're able to find more ways to use that data effectively. So what I want to switch to next is don't get hung up on just Hadoop, understanding it's about the data. Now, when you build data warehouses, here we're talking about late binding. The main thing that I want you to understand from here is when you work with data warehouses, people understand it's going to take a time to be able to get access to that data in our traditional environments, where if you're working in a Hadoop environment, one of your goals is as soon as that data hits the disk, people that need access to that information, you want to give them access to start working with that data as quickly as possible. The longer those time frames are, the more it's unacceptable for your company doing business. So, one of the things that you need to do right is you need to design your data properly. Whatever your data sources are, you're going to start loading data into your Hadoop cluster. This is often referred to your raw layer or your batch layer, dependent upon whose book you're reading. This is ultimately the source of truth for your information. With Hadoop able to store large volumes of information, you want to be able to keep that data in a Hadoop cluster until it has no business value, or the business value it represents isn't worth storing it on disk. Until then, you should be keeping it inside of your Hadoop cluster. George is going to talk about some of the different methods that you can use when you ingest that data. But since Hadoop allows you to store data and you're not modifying it, you're loading new data in, then you want to make sure that this source of truth doesn't change, because one of the things that happens when you're in data warehouses, people transform, aggregate, filter, and modify that data. Well, if anything's done wrong in a traditional data warehouse, people often have to go back for weeks or months to fix that corruption. But if this data doesn't change and it maintains your source of truth, then you can always rebuild new versions of that data from it. Well, whether you're working with a traditional data warehouse or a Hadoop cluster, that unstructured data, that large volume of data, is often not in a form that you want to work with. And people talk a lot about how great Hadoop is in working with unstructured data, which is true. However, your analytics and your BI tools are not good at working with unstructured data. So one of the key things that you need to do is get that raw layer, and you need to transform that data into a form that you can begin to work with. Now, once you put it in that form, you can start doing analytics. You can start working with different SQL tools that are out there. However, when you're at this work layer, right now, you may not want to go through all the data. When I work with certain types of information, I need to be able to get that faster. So often what companies will start doing is, at this level, start filtering, massaging, and putting the data in a form where they can return it very quickly. So anybody that's worked in a data warehouse and you've built materialized views to put the data in a format where you can return it quickly, that's essentially what you're doing here. Then you get into your gold storage tier. Here's where you're putting the data in a form that you can work with it as well. But often you have certain business units and certain types of reports that have to come back faster. So often people will massage it to a faster tier, and this is often referred to as the access tier or the speed layer. And the reason you build this is I need to return this data extremely fast. And this is what more of your business users are going to be working with. As you go further down the stack of these data layers, it's going to be more of the data scientists and your technical analysts that are going to be working with this. Now, the one thing that you're going to see is when you have data scientists and analysts looking at this data and they're able to look at it faster, consistently in customers that I go to, those data analysts and those data scientists understand the value of being able to look at that data faster. On their own, they start becoming more technical, because the further you go down in these layers, you do need to be more technical. But because they're all about the data, you'll see that they're going to start moving there on their own. So anybody that's come from a data warehousing environment at a high level understands the roles of these data tiers. And so here's what I want you to be thinking about as you move into a Hadoop environment. All that knowledge, all that data management, all that data governance. Use those same skill sets to get the data to what you need for your organization.
All right, guys. So let's talk about the reference architecture, right? So that was the setup. There is one benefit of going last at a conference, and that is you get to actually look at what the other sessions are all about, because there's common themes, right? And because you can do that, you can start to emphasize things that maybe people have missed, right? And that's what I'm going to try to do, because at this point, you guys know what Hadoop is, or a general sense, and so forth. So I'm not going to rehash things that you guys already have talked about. So think of Hadoop, the cluster, as an ETL grid, or an analytics grid, or exploration grid, or all the above based on your use cases, right? So the first step in the reference architecture is extract and load. This is something that you probably heard in a bunch of other sessions and so forth, right? The key to extract and load, any source you can extract into the grid, right? And I think that's something that probably the different sessions have continually focused on as well. What I haven't heard too many folks say is not just different heterogeneous sources, but different heterogeneous transports as well, right? So SOAP, REST, your ESB, messaging, right? Because if you're going to integrate Hadoop into your ecosystem, right, you're going to have all of those transports where data is moving from. So it's important that the platform be able to support not just multiple data sources, heterogeneous data sources, but heterogeneous transports as well. And the Hadoop platform allows you to do that, right? And so you see a number of things, right? Web HDFS, Scoop, FlumeNG, right? So FlumeNG allows you, it's a component that allows you to stream messages in, right? So you're using TIBCO, or you're using Mule or Camel, right? How do you consume messages off of those buses and into Hadoop? Flume might be a great source, right? You've probably heard of Scoop over the last couple of days. You've got relational data stores, right? To move data bidirectionally between those stores into Hadoop, that's a good component to use, possibly, right? Other things, there are, Web HDFS, right? So think REST, right? So if you guys are a REST shop, or if you're integrating with any of these integration frameworks, right? Being able to create a REST endpoint and to move data into Hadoop, right? So there's a number of different components, right? And there's best practices of how to use these components and so forth, right? So for example, Scoop is relational data store to move data to and from Hadoop. But do I use Scoop for any relational data source? No, right? So I'll give you an example. I do my initial load into Hadoop, right? And Scoop typically uses JDBC connectors. And that data source is serving an application that has a strict SLA, right? Do you think your operations or your governance team is going to allow you to move 3 terabytes of data from your relational data store that maybe spins up hundreds of connections, right, that affects that application? No, right? So typically what we've seen in those situations is you actually take a dump of the database, right, for those initial loads and so forth, right? Because you don't want to affect the applications that have those strict SLAs that depend on those data sources, right? So it's not a clear-cut answer. Just because it's a relational data store doesn't mean you use Scoop, right? We see a lot of things where we actually take that dump and you chunk it up into multiple files, and you essentially parallel import into Hadoop using things like Web HDFS and so forth, right? Just because you have streaming doesn't necessarily mean you use Flume, right? Just based on the fact that messages by itself is small, right? So the point I'm trying to make is there's a number of components that allows you to bring data in from different data sources and across different transports, and then there's also best practices around which component to use, right? And sometimes that's a function of SLAs, right? That's a function of who accesses that data, governance, right, and all those things, right? But the point is, there's a component that exists. Now, we often hear bring raw data into Hadoop, right? And the value of that, why the session is called ETL 2.0, is that it differentiates itself because let's say I'm pushing out a new application, right? I've got a release next week. And in that release, I'm adding additional tables. I'm changing the schema of existing tables. What typically happens, right? One, you push that application out, but the data warehouse on another release will make the changes on their back-end data marts and so forth to actually access that data, right? But the business analysts don't have access to that immediately when that application gets released. Or two, you delay that release until the downstream data warehouse changes occur, right? The beauty of Hadoop is that when that application goes into production next week, there's very little that needs to change on that intake side, right, to immediately have that data available in Hadoop if you're dealing with raw data, right? And that's a very important point because what that means is my sources can change, but I still have access to the data. The business analysts have access to that data, right? And we'll get into from a processing perspective. So I bet some of you are asking, okay, I get that, but what about all the processing you're doing within Hadoop? Don't that have to be changed? Not necessarily. And we'll talk about how we can accomplish that. So that's the first part of this reference architecture. Extract and load, cross transports across sources. The second point, and this is something that I've not heard too many of this, obviously I haven't gone to all the sessions, but too many of the sessions talk about. It's great that I can bring the data in its raw form. That's awesome, right? But I don't know too many processing systems where I can actually query or analyze that data in its raw form, right? You need metadata around it, right? So when I talk about metadata, I'm talking about projecting a schema on top of it. I'm talking about the location of that data, such that I'm not hard-coding locations of HDFS file directories. I'm talking about the format of that structure, right? The key here is let's project metadata onto that raw data set, right? And be able to essentially share that metadata across all my processing engines. And that's what something like HCatalog allows you to do. I haven't heard too many folks talk about HCatalog, right? And that's something I want to dive into in a few minutes, right? But second step, raw data now in, let's now apply metadata to. The third and fourth steps is now I've got this raw data, I've projected metadata on it, now I can use my processing, whatever processing tool I want to do to transform that data, the transformation of the ETL paradigm, right? So you've talked, I bet you guys have heard about Pig and Script, or Pig and Hive and MapReduce and other external tools. But the key point here is that each of these processing tools should be able to tap into a single metadata repository, right? And that's the third and fourth step. One interesting thing, number 3 there, right? Often there's a need to know when my data has been loaded into Hadoop before I can start processing it, right? Let's talk about an actual production system, right? Let's say every night I do an incremental load, right? Based on the delta changes that happen during that business day. When do I know when that load has been finished, right? Time-based, right? Maybe that load should finish by, 5 a.m. every night, right? So, or you can query, right? You can ask, is the load complete? Is the load complete? Is the load complete, right? To kick off the actual workflow. Or you can do more of an event-based model, right? Such that when a partition or a table or a file within HDFS or a directory has been loaded, let's push a notification off into my metadata system to say, listen, this partition that's metadata in itself is completely loaded. Go ahead and kick off whatever processing that needs to happen. So HCatalog is not just a metadata repository, but there's event-driven mechanisms built in to do eventing and to be able to chain processing engines together. Okay, so that's step 3 and 4. The fifth step is you've transformed the data, you've cleansed it, you've aggregated it with different data sources and so forth. you might want to push it out to a downstream system for maybe real-time access where there's strict SLAs, an OLTP type of application, right? So there's mechanisms with the component not just to import data into the platform, but also to exchange it and push it out to other systems, right? And that's really 5A. 5B and 5C represents the other use cases. I'm not going to go into that, but that's around visualization, that's around running analytics, that's tapping into the Hivesware where you've got Tableau or Excel connecting to it and so forth, right? But the point here is steps 1 through 5A represents the common reference architecture for ETL processing that we've seen out there with customers, okay? So let's focus on a couple of these steps, okay? So one is HCatalog. So what is HCatalog? So I talk a single metadata repository, right? The best way to describe HCatalog is to talk about what happened when HCatalog didn't exist, right? When HCatalog didn't exist, and I needed to write a pig script, I had to define metadata and schema within pig. If I wanted to use Hive, I had to create a schema within Hive. If I want to write a MapReduce Java program, I had to create a schema and the file formats and so forth within MapReduce. The problem is they weren't sharing with each other. So you got redundancy of metadata in whatever processing tool you used. It doesn't make sense, right? HCatalog allows you to have that single repository such that Pig, Hive, MapReduce, or whatever processing engine you want to tap into that repository and access that data, right? 2 is, not only are we opening up the processing tools within the platform to access the single metadata, but we actually have a RESTful API on top of HCatalog, right? And now what that allows you to do, it allows the ecosystem, Microsoft, right, Tableaus or Platforms or data mirrors out there to tap into that metadata, right? So think of spanning queries, right? A common use case I get in the field is I want to be able to query my data warehouse, which has maybe 2 months worth of data, and query that data with 10 years worth of data and keeping within Hadoop, right? So, you know, Aster and Teradata, right? They've built these spanning queries capabilities, and that's possible now because they tap into the metadata repository using the RESTful API. So these external systems that live outside of the Hadoop platform, right, can tap into Hadoop to query the metadata, to understand for this table where the partitions are, where they're located in HDFS, right, where the blocks are located, what the schema and structure it is, and be able to marry that with the schema or metadata that's within that external system. So to be able to join table X from Teradata with table Y in Hadoop Hive, it's possible, right? And those exist now, and HCatalog allows for that. So best practice, right? Use HCatalog to manage metadata, or you're going to be replicating that throughout, right? Another interesting thing with HCatalog is I talked about the scenario when I'm releasing that application next week, right? And I said, beauty with Hadoop, you don't really have to change your ingest flows dramatically to capture that data when that application is released next Friday, right? HCatalog also has the capability as when you're defining partitions, and think of partitions as just another metadata of that data set, such that each partition can have schemas, evolving schemas. So on January 1st, I released an application, and that, let's say a table has 30 columns, right? Next week, when I'm deploying that application, right, it added an additional 10 columns to it, and I remove a couple columns or whatnot, right? You can actually create partitions for each of those evolving schemas, right? And Hive and HCatalog is pretty forgiving when you're actually joining partitions together where the fields or the columns don't line up. That's another key capability, such that my downstream systems can change. I can ingest that data dramatically. Even my processing, right, can accommodate for those changes. Pretty powerful. So here's a sample example, right? So Twitter has what's known as a streaming API. What that means is, in your Twitter account, if you don't modify your default profile, every tweet that you push out, I can tap into, right? So it's a push-based mechanism where I tap into that streaming API, and I get every tweet, and I can filter on it and so forth, right? And so what the Twitter streaming API gives right, is a JSON structure. This is just a pseudo. It has a number of additional attributes and so forth. Right? So I've got this sample JSON tweet. Right? I've landed it raw into HDFS. Right? I can take it. I don't want to modify it. Give it to me. Twitter all the time changes their JSON schema and structure. Right? I've landed it in HDFS raw, and now I'm using Hive and HCatalog to project that metadata on. So what you see highlighted in green represents really the three types of metadata. The first represents the table, which assigns an alias, right, to the location, right? Where in HDFS do I want to project my schema? The second represents the schema that I'm projecting, to be able to be queried by Pig, queried by Hive, use it with MapReduce. And then that row format 30 represents the formatting of that structure. The key point here is each of those three metadatas can now be shared across all processing engines. Okay? So let me focus on the processing side, right? So there's a number of different processing engines within the platform. I'm not going to go through it. It's the last day of the session. I'm assuming you guys have, in one way or another, been exposed to this, right? But I do want to talk about common ETL processing patterns and some best practices around that, right? Experience in the field, you can essentially equate a common ETL flow into 4 categories, right? Long-term data retention, where you're usually taking that data, maybe compressing it, and essentially archiving it for a longer period of time. Staging it for data exploration. You're taking that data, maybe aggregating with other data sources, and you want to actually explore that data set in the transform form. Cleaning up that data, data cleansing, and enriching that data. Common ETL processing flows. So I want to take each of these processing patterns and talk about it with respect to a couple of dimensions, right? Compression, buffering, data format containers, logical processing tiers, right? I'm not going to go too deep, so don't get scared. So one is compression, right? In terms of performance, the biggest bottleneck is rewrite I/O in Hadoop, typically. So if you can compress that data set, make that data set smaller in nature, right? So typical compression ratio, 7:1, right? You can take that 10 terabyte file and make it 3, right? You get benefits, right? And there's a number of compression algorithms that are supported, right? So there's some decision to be made what type of compression algorithm that you want, right? The trade-off being between space and time. Do you want a faster compression algorithm, or do you want one that consolidates more, right? And that's going to be a function of the processing pattern, right? So bear with me. I'm going to talk about the easy dimensions, and I'm going to tie it then back to that processing pattern, because typically there's some heuristics rule of thumb that you can say, for this processing pattern, right, use these aspects, these dimensions that I'm going to talk about. So compression being the first dimension. Another dimension is buffering, and what I like to call the suitcase pattern, right? So when you guys came to the summit, you guys were packing that morning, right? You took clothes out of your rack, put it into your suitcase, right? You're compressing data such it can be easily transferred, right? And then when you got to your hotel, you had to unpack it, right? Same thing really applies to Hadoop, right? Because if you're talking about streaming events by in itself is very small, right? And you've heard, I think, over the last couple of days, typically, Hadoop deals better with larger data sets, to stream larger data sets, right? So the suitcase pattern is, can I buffer these messages together to a block size, right? That's optimized for Hadoop, and then compress it, and then store it into HDFS, right? And that's a common practice, best practice that we've seen. Not just compression, but being able to buffer smaller events into a larger data set, and then compressing it, and then store into HDFS. Now there's caveats to this, right? So there was a session where BlackBerry was talking about this, right? There's approaches where maybe you want to do that buffering within Hadoop, right? You want to take advantage, because they were saying, 100 million events per second, right? And those type of ingest rates, maybe you want to bring it as in and then run MapReduce across that larger data set to be able to buffer it and so forth, right? But buffering is key. In terms of how you buffer, a common way is using time series, right? Buffer 1 minute's worth of data, 10 minutes, 1 hour, right? But usually time is a good way to be able to determine how frequently you buffer and so forth. And then the last dimension is different data format containers. So there's a lot of information on this slide. I hate this slide. So don't look at it. So first, sequence file, right? So if I'm a newbie to Hadoop, right, when I usually work with customers, they'll say, listen, I'm working with 3 terabytes of data, and these Hive queries are taking just so long, right? And the problem is the data comes in as text, and they'll leave it as text, right? Text is not very optimized for MapReduce, right? So there's different data format containers based on what you want to do with that data where you can actually optimize it. And that's really what a data format container is. So a sequence file, think of sequence file as binary key value pairs, right? So I can take 100 files, and for each file, I create a key, which could be the file name, and a binary representation of that file. And I can do it for all 100 files, right? So it's a great container because it's key value, it's binary, it's smaller in size. And key value is great because MapReduce works in the key value paradigm, right? And it's great when you're talking about consolidating a bunch of smaller messages into a format that's suitable to be processed. So sequence file is one. Avro file is very similar to that. One of the nuances with Avro is that you can actually embed a schema into it. So it's a great way if you've got, for example, the Twitter. Twitter, I would say every couple of weeks changes their JSON schema, right? So if that's the case, if I can embed my schema into the actual file itself, then I can accommodate for evolving schemas and so forth. That's the key difference between Avro and sequence file. And then there's RC file, right? Up until a couple of weeks ago, the best practice is if you're working with Hive, is use the RC file format, right? And RC file, it's what's known as a columnar format, right? So if let's say I've got a table of 100, let's say a couple million rows, and I've got maybe 200 columns, right? And most of my queries only access 10% of those columns, right? If I wasn't using RC file, when I query, let's say 3 of those columns, it's doing full table scans across all the columns of that table, right? A columnar format solves that problem in the fact that it's stored in terms of columns of values, right? So you're actually only accessing the columns that you're accessing within the query, okay? And that's RC file. Just a couple of weeks ago, ORC file was introduced, right? And ORC is an optimized version of RC file. If you're working with Hive and you're optimizing it, you should seriously look at ORC file, right? And how it's different from RC file is that now we've built in indexing into the file format itself, right? So you're essentially, so things like counts, averages, and so forth are metadata associated with that file format, right? So you're essentially able to skip entire stripes of data based on the indexes that are built into the ORC format. Okay, so again, a quick primer on the different data format containers out there. So let's wrap everything together, okay? So we talked about those processing patterns. And again, these are heuristics. It's going to vary, right? These are just good rule of thumb to follow, right? Long-term data retention, right? That tier path is that tier thing that my twin George showed, right? It's how data flows from each of the tiers, right? So that's where you come into raw and you push it into gold because really the use case is to archive that data set, right? You want to use a compression that gives you better compression, right? Because probably compaction is more important to you than speed in that case because it's just long-term data retention, right? And you want to probably, in that case, use Avro sequence files because that gives you typically better compression ratios, right? Staging for data exploration, right? That's where you essentially want to be able to put it into a form where it can be easily, very fast queried, right? And that's the ORC format, right? Data cleansing, where you want to quickly do work, it's transient in nature, right? Maybe you want to leave it in text file, right? or push it into Avro and so forth, right? So the point here is processing pattern and being able to evaluate it across these dimensions: compression, buffering, file formats, and so forth, right? And these are typical things that you start to do when you're actually starting, push this into QA and actually test this in terms of optimization and so forth, right? Be it if you're working with Hive or Pig or whatnot. So I've got 31 seconds, perfect. So the question you're dying to ask, right? What tooling do I have to orchestrate these flows? If you're coming to an ETL 2.0 modernization, there's probably a lot of ETL developers there, right? If you're an ETL developer, you're experienced with really high-level tooling, data stages, informaticas, and so forth, right? And that's traditionally where Hadoop has struggled, right? There's tools like Talend that allows you to do drag and drop WYSIWYG, so it abstracts away Pig and Hive. Informatica and the data stages are starting to build those technologies, but typically those aren't pushed down ETL transformations. Those are transformations where you've got a scoop connector where it's exporting it into the ETL grid, doing its work, and then pushing it out. Defeats the purpose of Hadoop, right? But they're working on push-down analytics and so forth. One thing what we're doing in this to make this better is Falcon. There's been a number of sessions on Falcon. It was mentioned in the keynote, right? But it's to manage data lifecycle, right? All of these best practices that I'm talking about, can they be integrated into some kind of reusable component where I'm not even thinking about that? Based on my data flow, based on my processing flow, based on the data set size, right? It should just generate, right? Just like ETL traditional tools have done. And that's really one of the key aims of Falcon, right? Is to be able to provide a DSL which abstracts away things like Scoop and Flume and Pig and Hive, right? And all of those, and be able to work at a higher level, right? And that's in a nutshell what Falcon is. And those are where, traditional ETL, right, where it's starting to come to the tooling, because that's typically where Hadoop has lagged behind. It's the tooling around these ETL transformation tools. And I think Falcon is going to be a game changer when it gets GA'd in the community. Questions? That was my last slide.
I have a question for, so do you have a suggestion for collecting metrics, or how do you basically collect, this metadata around your processes, ETL processes?
So I heard two questions. One is, how do I tap into metadata? And then one is, how do I capture metrics across the different flows or different steps across my ETL flow? So the first is there's a RESTful API, so you can tap into that metadata. I think that addresses your first question. And then the second is traditionally Hadoop has a number of counters built into each of the services. I think you're probably well aware of that. But there's another things where the ecosystem is helping out, right? So Splunk just released Hadoop, the Splunk Hadoop Analytics, right? Where it actually taps in and it's able to index all of the logs, all the audit files that gets generated by every service within the Hadoop ecosystem, the name node, the job trackers, the Hive server, the Hive Metastore, all those stuffs. So different toolings and so forth. I'm getting the axe. So if there's any questions, guys, we'll stick around. Grab a beer.
Thanks, everybody.